right, so this is the premise here. You wake up on a boat next to an island. You have no memory of how you reached there. So you do the natural thing. You jump off the boat and you swim towards the shore. Let's continue. So as you swim towards the shore, this happens. Let's see what happens here. Right, so read what the octopus is saying. That's the first clue. Obviously, with one clue, you can't figure out what's going on in the island. But apparently, he has cramps, like his muscles cramp up on certain days. He cannot move, right? And he wants your help. This is your first question. I know the question says to work the 3 significant figures. So, you know, get started with the question. You're going to have a 5 minutes. Don't feel shy about sending your answers. Now, there are 2 parts to this question, part 1 and part 2. Obviously, if you're sending the answer for part 1, please let me know, hey, it's part 1. And if it's part 2, same thing, let me know. Good luck, and I await your answers. The first thing you will notice in this question, they ask you for the area in centimeters squared. You will notice that they gave you, well, the length of the object in meters. We have to multiply it, obviously, by how much? 100, right? So it's 120 centimeters, because we have to convert it to, you know, to centimeters. So that's, I guess, the first trick in the question. Also, I think I mentioned a while ago that if you have a cylinder, right? You know, when you are buying foil paper, it is coming in a kind of cardboard cylinder. I think I mentioned that if you were to cut a cylinder, like slice it and open it up, you will get what? A rectangle. So I think everyone is familiar with that from a few weeks ago. Also, the distance around a circle is its circumference. So let me just use the blue here. Let's get a different color. So if I were to start over here and journey all the way the top around the lid, obviously I'm going to get a circle. And of course, that blue line, its distance is the circumference. Okay, that's the circumference. I'm just saying, if the circumference, let me say we found some way to work out the length of that blue line. And I'm just saying if the length of that blue curved line was 50 centimeters, obviously, if we were to open it up, the distance of the rectangle, of the top of the rectangle, would also be what? 50 centimeters. Now, the same, and how would we find the curved distance, right? The circumference. Didn't I give you a formula to find the circumference of a circle? I put CIR for circumference. Isn't circumference 2 multiplied by pi multiplied by the radius? Or there's another formula, pi multiplied by diameter. And remember, the diameter is twice the radius. Would I also, I'm just saying, would I also get a rectangle? Let's say I had this. Let's say I had half a circle. If I had half of a circle, so I took the cardboard cylinder and I know I only take half of it. If I were to open this out, would I also get a rectangle? Well, what are your thoughts on it? If it was just half of the cylinder, so I slice it down the center, I would also, right, I would also get a rectangle. But obviously the rectangle will not be as long. It might be half, and in fact, it will be exactly half. This distance over here, this curved distance here, that's obviously how much? Half the circumference. So if you were to wanted to find the curve distance in this case, you could, use any of these formulas over here to find the circumference, but you would have to eventually divide it by what? 2 to get this distance on top of the rectangle. Everybody with me so far? Right? So that should help with the question, right? All right. So what I'm going to do now with this question, since we're finding the surface area, I'm going to open out this shape, right? Now tell me if this makes sense. Now they didn't draw part of the shape because you have to imagine it. Everyone agrees that to the back of that shape, there will be a semicircle. Tell me if this makes sense. If I were to completely open up that shape, the center part is going to give me a rectangle, right? The front is going to flap out and the back is also going to flap out. So to the front, you will get a semicircle like this, something like that. Sorry, it will actually be a little bit smaller. And behind it, I will get another semicircle. Can everyone in this class imagine that if you were to fold back the center part and fold back in the front and back part, you would get back the original shape? Imagine it. It's very, very important, right? Make sure you can see it. Great. So all we need to do now is find the area of each section. And if we were to add it up, we would get what? The total surface area of the shape. Okay? So let's do that. Can you all help me find the length of this straight line here? I'm going to label it A, B. We already know from A to C is 120 centimeters. That's easy. But what's the length of AB? No, Anjana, it's not 30. Remember, the diameter is 30 from here to here. But the curved part is the distance from A to B. Remember, when you open out that curved part, then you will get AB. And I guarantee you, AB, when you open it, will not be 30. Christian is not 15. Check it back. Remember, I showed you all something about the circumference of a circle. And if you're doing half of it, you have to take the circumference and divide it by 2. And to find the circumference of a full circle, it's pi multiplied by diameter, right? So we have pi. And how much is the diameter? 30. But this is for a full circle. But let's still get it for the full circle. And then afterwards, we can just simply divide it by 2. Pi multiplied by 30. Make sure you type it in on the calculator. You could use the pi button, or you could use 22/7. But make sure that you physically see something close to this. 94.25 centimeters. Make sure you see it on your calculator. But this is for a full circle. For half a circle, we have to take the 94.25 and divide it by 2. And when we do that, we get roughly, that's 94.25 divided by 2, we get roughly 47.13 centimeters. I'm going to 2 decimal places, all right? If you're slightly off with the decimals, don't let it bug you, all right? So from here to here is 47.13 centimeters. Couldn't we find the area of the rectangular part now? Because it's in the area of a rectangle, length by breadth. So find the area of the rectangular part. 47.13 multiplied by 120. I am getting roughly 5655.6 centimeters squared. Could you all confirm that? And you see this concept of taking a cylinder and opening it out. It's super popular in the CXA exam, like really, really popular, especially for those who write in the paper trees, right? I can't stress on how popular that is. All right. Now, we still have to find the area of each of the flaps, okay? Now, I think everyone can agree that if we take item 1 and add it to item 2, right? We are obviously going to get what? A full circle. So all we have to do is find the area of a full circle. To find the area of a full circle, we know it's pi multiplied by radius squared, right? So how much is the radius of this circle? Remember, the diameter is 30. So that means the radius is 15. So it's 15 squared. Find the area of both flaps combined in one shot, which is essentially a full circle, right? Pi multiplied by 15 squared is roughly 706.86 around that centimeters squared. Make sure you see it on your calculators. So that means the total surface area, right? For the surface area, we're not including the base, right? It's just the outer part, the part that you can actually see, right? So the total surface area, right? You just have to add these two values now. Add those two values and you will get the total surface area. 706.86 plus 5655.6. I am getting this for the total surface area, put SA for surface area. 6362.46. And of course, I have to put what? Centimeters squared. Right, so with that in mind now, we can actually do the real question. Well, what it was asking us for, because I misinterpreted the question. Well, not misinterpreted, I didn't read it properly. Right, so let's quickly finish. I will work out the rest of this question quickly because I think I've wasted enough time. Now, in this question here, they ask us to use pi as 3.14. So when I'm working out part 1 and 2, I have to make sure and follow the examiner's instructions, okay? So the first part, they want us to find the area of the cross section. The area of the cross section is what I'm shading in pink right now. That's half of a circle. So to find the area of half of a circle, it's pi multiplied by radius squared. But since it's half of a circle, I have to divide it by 2. So 3.14, which I'm supposed to use pi as 3.14, multiplied by the radius squared, 15 squared, and then I divide it by 2. Please confirm you got this on the calculator, 353.25 centimeters squared. Right. Right. Now they ask us to round it off to 3 significant figures. 3 significant figures means that we only care about the first 3 values. And if the fourth value is 5 or more, right, then add 1. All right. All right. For those who didn't get this, remember, it's just a matter of typing in pi multiplied by 15 squared divided by 2, but you're using pi as 3.14, right? So if you didn't get it, you know, just try it back quickly and see if you could get the 35. You know, probably just type something wrong on the calculator, error, right? All right. So for the area, I have to round it off to 3 significant figures. So it's 3, 5, 3. All right. Right. All right, so just to clarify something, the area of a circle, right? The area of a circle is pi r squared. I'm pretty sure about this, all right? The area of a circle is not 2 pi r squared. I'm 100% sure about that. Anybody seen any mistakes on the screen? Let me know now. I get in some people are saying I'm doing something wrong. I'm pretty sure the area of a circle is pi r squared. And of course, the reason I am dividing by 2, right? The reason I am dividing by 2 is because it's half of a circle. So that is why I am dividing by 2. All right, so to find the volume now remember, this is a uniform shape. This is a uniform shape, right? For a uniform shape, right, the volume is what? The face area multiplied by the length of the object. Now, I find the examiner could have been a little bit clearer, because to me, I could see students doing 2 things in this question. When I'm using the face area, should I use the 3 significant figures, or should I use the 2 decimal places? Yeah, I find the examiner could have been very, very specific on which one to use. All right. And honestly, I really don't know which one he wants us to use, and I don't think anybody on the planet would know either, right? But I'm going to go with the original value, right? I'm going to go with the original value, and after I get that value, I will round it off to 3 significant figures, right? So it's 353.25, and the length is how much? 120. So I'm getting roughly for the volume 42390 centimeters cube. But that is the volume, and they want us to round it off to 3 significant figures, which means we only want 1, 2, 3, right? Right? So we're getting 4, 2, and since the 4th number is 5 or more, we have to add 1 here and put back 2 zeros as fillers. Centimeters cubed. All right, so those are the answers. Anybody got these answers way before me? Like when you had a chance to work it out on your own? All right. Let's see what's going on in this slide. Remember, there's a little mystery on the island. So apparently on the island, remember, there's a strange island, right? There's a bridge that appears and then disappears. It just keeps appearing. Sometimes it's there, and then sometimes when you go back, the bridge is not there. What could be going on that island? All right, so this is the question I was looking at this morning, right? And this is why I had started to automatically find the surface area, because in this question, they do want you to find the surface area. Now, when we say the surface area, I have to assume they're not talking about the underneath of the object. It's just the part that you can see, right? That's for part 3. When I ask you for the total, I'm hoping it's that, the total surface area. Good luck. 1, other answers are coming up. So for part 1, right, what they're asking us to do is the cylinder part. You're just focusing on that part. You're just unfolding that part. And like I mentioned before in the last question by mistake, you would get a rectangle. Now, the top of the rectangle over here, right? That distance would be equal to the circumference of the circle. So and it's a full circle this time. So to find the circumference of a full circle, is 2 multiplied by pi by the radius, or like I said, you could use pi multiplied by diameter. Anyone is going to give you the same answer. But the examiner gave us the radius. The radius is 3. If you look carefully, it's 3. So we just have to say 2 by 3.14 because the examiner told us to use pi as 3.14, and the radius is how much? 3. So let's work that out. 2 by 3.14 multiplied by 3, and I'm getting 18.84 centimeters. I'm double checking that one. 2 by 3.14 by the radius is 3. Yes, I'm correct. And we know the distance from here to here. You can see it plain from the diagram is 8 centimeters. So it's just length by breadth, and that will give us the answer for part A. Anybody got roughly this? I only saw a few people send this answer, 150.72 centimeters squared. Double check it, make sure you see it. The moral of the story, if you take a cylinder or even half of a cylinder or a piece of a cylinder and you unfold it, you always get a rectangle. Right. Now for part 2, it's pretty easy. The only reason part 2 is easy is because the examiner basically gave you the formula. On top, it's half of a sphere. That's half of a basketball. The examiner had given you the formula to find the surface area of a full basketball, a full sphere. So in other words, all you have to do is say pi r squared. Remember, you're using pi as 3.14, and since it's half of a sphere, you divide your final answer by 2. Okay. It's 4. The radius is still 3. So you work that out and you divide it by 2. I am getting 56.52 centimeters squared. Right? And we're almost finished. Now, remember in part 3, right? To me, the examiner isn't being clear here. He or she is not being clear on whether to include the underneath, the base of the object as part of the surface area. So I'm not going to. So to find the total surface area, we just have to do what with our 2 answers? Add them, and then we're completely finished with part 3. For my final answer, you can confirm it. 207.24 roughly centimeters squared. Right, so we're going to our next part of the island here. This bird appears, this dodo bird. So you have to read this clue. So apparently there's a dinosaur loose on the island. But he only appears, the dinosaur only appears when the bridge disappears. Right? So when the bridge is there, the dinosaur is not there. But the minute the bridge disappears, the dinosaur reappears. So I hope you guys are following the clues to try to figure out what is wrong with this island. Good luck with this question. Take a 5 minutes, that should be enough time. Remember, this is a uniform shape. So the volume of a uniform shape is the face area multiplied by the length. the examiner was so nice to give us what? The area of the face, which is 144. So we just have to take 144 and multiply by the length, which was 30. Right? So 144 multiplied by 30, and we're supposed to get 4320 centimeters cubed. Super, super easy. You just have to find the total surface area now. To find the total surface area, you're just going to find the area of each face. Now the good news is every face has a face directly opposite it with the same exact dimensions. So when you find the area of one face, you just multiply by 2 one time. So you incorporate the face on the opposite end in one shot. Right, so I'll give you like a couple of minutes to do part 2. Now, remember they said the front was a square, right? So if the area of the square is 144, then the dimensions of the square have to be 12 and 12 centimeters. Just like, I think that was a primary school question, where they give you the area of the square and you have to work backwards to get the area, sorry, the length of each side of the square. So now we have the square. Remember the length of the side of the square? This cuboid is going to have 6 faces. So I'm just going to call this face A. I'll call this one B, and the one to the top C. Now A is going to have an opposite one on the other end. B is going to have an opposite one on the other end. And of course, C will have an exact copy of its face below. So the area of face A is how much? 12 by 12, right? And since we have 2 of them, we multiply by 2. For face B, the area is length by breadth, 30 by what? 12. And we have 2 of those faces, so we multiply that answer by 2. And for C, it's length by breadth again, right? You're going to get 30 by, well, he's 30 by 12 also. And you have 2 of him, so you multiply by 2. So when you work out all of these areas, you just simply add them up, then, you know, you get the total surface area. So let me work this out. I am getting, when I work this out and I add it up and everything, I am getting 1728 centimeters squared. That is what I am getting. Right, so right, so I'm watching everyone answers here. And remember, you have to get the units correct as well. Huh? You have to put centimeters squared. For those who got it wrong, just check it through. And of course, let me know if you finally saw where you made your mistake. Oh, before we move on to the next slide, we have this particular question to do. The area of a sector, right? What length of a sector, perimeters, and whatnot. Let me give you some formulas, because to be fair, the formulas the examiner is supposed to give you the formulas. Remember, for a full circle, right? For a full circle, if you wanted to find the area, right? We all know it's pi r squared. But if they give you a sector, which is only piece of a circle, right? And they give you the angle in the sector. So they have to give you the angle. So we're going to call the angle theta. To find the area would be pi multiplied by radius squared, but you have to multiply by the angle and then divided by 360. If you wanted to find the length of the curved part only, you call this the arc. To find the length of the arc, what you would do is take the formula to find the circumference of a circle which is 2 by pi by r, or pi by diameter. And to find the length of that portion of the circumference, you multiply it by the angle and once again divided by 360. So I think you have everything on the screen now to get the question correct. Good luck. Right. Open up. To find the length of the minor arc, you're going to use the orange formula, right? So it's going to be what? 2 by pi, and the radius is how much? 15. The angle is 45, and you divide it by 360. Remember, the examiner said to use pi as 3.14. So let's type that in. 2 by multiply by 3.14, multiply by 15 by 45 divided by 360. And I am getting the 2 decimal places, right? Because that's what the examiner said. 11.78. I saw a few people send that answer, right? So we know the curve part is 11.78. Now in part 2, they just ask us to find the perimeter. So we're trying to run along the shape. Now, if here is 15, isn't here another 15? Because 2 radius will obviously have the same length. So all you have to do is pretend you're running around the shape and add up how much centimeters you ran. So to find the perimeter, you add in 11.78, add 15, and then you add back another 15, right? Anybody else had this particular answer? 41.78 centimeters. That to me is the perimeter. Right. So I'll give you a minute again now to do part 3. That's to find the area. And you have the formula. So you have no excuse. Right? So good luck. Let's see who's correct. To find the area, pi multiplied by radius squared. How much is the radius? That's not radius is 15, so pi by 15 squared by the angle, which is 45, and divided by 360, right? We're using this formula here. 3.14 multiplied by 15 squared. And I'm getting 88.31 centimeters squared. So double check your answers, right? I think some people forgot to press the squared over the 15. Remember, it's radius squared. So it's 15 squared. Right, so double check it and make sure you end up with 88.31. All right, so see what's going on here. Right, so this is on a different part of the island. One of the heads comes out of the ground. So apparently this head keeps record of what he does every day, but somebody keeps erasing the book. All right. Good luck with this question, right? So I think we did the hardest question for the day already. You see the one with the cylinder where we had to cut it open to get a rectangle? That's the hardest question for the day. For part A, they ask us to do what? Just find the volume. So the volume of a cuboid here is just length by breadth by height. Right? Simple stuff. 25 by 8 by 36. And let's see what I get here. 7,200 centimeters cube. Easy stuff. For part B, the total surface area. Remember, for each face, there will be an opposite face on the other end with the same exact dimensions. Right? So to find the surface area, put SA will be 25 by 8. Multiply that by 2 plus 36 by 8. Multiply that by 2. And which face am I forgetting? The 25 by 36. And we multiply that by 2. Right, so let me quickly work this out. Anybody got roughly this? Not roughly, exactly this. 2,776 centimeters squared. Double check it, right? A lot of people are telling me yes, so most likely I'm correct. Well, easy. You just have to divide the volume by 6, right? Because it's 6 what? Boxes of, and all of them have the same size. So you just have to take this and divide it by 6, and you will get 1,200 centimeters cubed. Now, the other one is, right? So let's say this is the smaller box here that I'm drawing, right? What it's saying is that the height of the smaller box is 20. Now, talking about part 2. Remember, we need the volume to be what? 1,200. So the volume would be what? 20. And let's just call it underneath dimensions, length and breadth. We have, remember, that's how you find the volume of a cuboid, right? Of a box. What two other values here, if you multiply them, we would get back 1,200. And there are plenty different combinations, right? For example, 20 by, let's say, well, what two numbers when you multiply, 1,200 divided by 20. You need two numbers, right? When these two numbers, they need to multiply up to 60, because 20 by 60 will give me 1,200. So what combinations, when I multiply them, I will get 60. It have plenty to choose from, right? It have 30 by 2, or it have 12 by 5, or 20 by what? 3. There are so many different combinations, okay? They just want one. If it was up to me, I would probably choose the middle one. But then again, it's up to me, right? It's up to you and me. Oh, they said 2 combination. Oh, all right. They said list 2 different pairs of combinations. So I would probably go with the 12 and 5 and the 20 and 3. Once again, you could choose any 2 combinations. All right, so let's move on to the next question. Oh, here's another part of the island. Right, so somebody keeps sending this person something, doesn't know the person. I don't know if anybody figured out the mystery as yet on this island. Like, what's going on this island? One. For part 1, the volume of milk in each cartoon, right? Oh, not too sure if this, it just, what if there's a trick? Length by breadth by height. 6 by 4 by 10. Did you all get 240 centimeters cubed? right? Just checking through your answers here. Great. Right. Now, the recipe calls for making ice cream requires 3 liters of milk. Now, in case you all didn't know, right? I'm not too sure if they mentioned it anywhere in the question, but 1 liter, right, is equal to 1,000 centimeters cubed. That's a standard comparison. How many cartons of milk should be bought? Well, let's divide it, right? Because so it could be 1,000 divided by 240. Let's see what we get. 1,000 divided by 240. And we're going to get how much? No, it's 3 liters. Sorry, it's 3 liters. My mistake. So it's 3,000 we have to divide by. So it's 3,000 divided by 240. We're going to get 12.5. But you cannot go in the grocery and buy 12.5. You can't walk with a knife and say you take 12 and then take out the knife and cut the other 1.5 and throw it into your basket. All right, you'll get thrown out the grocery, right? So how much you have to buy? You have to buy 13. You have to buy if you don't put 13, you'll get it wrong in the exam. You'll lose a mark. If you put 2.5, you're definitely going to lose a mark. So the final answer is 13. All right, so the next part. So what you're going to do is for 1 carton of milk, that's this guy here, we're going to pour it into a cylindrical cup of internal diameter 5 centimeters. All right. So that means this is a cylinder. How much is the volume, the formula to find the volume of a cylinder? Isn't it pi r squared by its height? Now, obviously, when you take the milk and you throw it into this cartoon, it's going to rise to a certain height. We know that. We just don't know the height it's going to raise to, sorry. But what we do know for sure is that the volume of milk, and when you pour it into the cylinder, it's going to be the same exact amount of milk. You're not going to get more milk or less milk, which means the volume is going to remain the same. So that means the volume in the cylinder is still going to be 240. They tell us to use pi as how much? 3.14. The radius, they give us the diameter of the cylinder, which means the radius is 2.5, half the diameter. And we have to square it according to the formula. And we're trying to find the height. Use your transposing skills to find the height or the letter H. So it's 240 here, and we have to work out this part here. 3.14 multiplied by 2.5 squared. This part over here is going to give us roughly 19.625. We want to solve for H. The 19.25 is a multiply, throw him across. You're going to get what? A divide. So 240 divided by 19.625. And I'm getting roughly 12.23 or something like that. Right? And they wanted the 3 significant figures. So they wanted a 1, 2, 3. So 12.2 centimeters. That is the height. Right, Jevon, you'll let me know if you saw your mistake. All right, so let's move on. Oh, there's a next cut scene here. So on one part of the island, there's a cave that's being blocked by a door. So apparently he forgot the secret knock. All right. All right. So we're coming down close to the end of class, right? So I'm not too sure if we're going to have enough time to work out this question, right? But you all want to take a screenshot of this question, because this one is going to take us a long while. But the good news is it's doable, because you know what this question is testing? They're testing your knowledge on if you cut this and open it out, you are going to get what? A rectangle, right? So I want everyone to screenshot this. I'm going to take off this annoying pink line here. Screenshot that question, right? Let me know when you have it. The island. That whole thing was a computer simulation. Like you were trapped in a computer simulation. I'll give you proof. Like I want to show you how the clues added up. Like I want to show you why this is inside a computer, right? Look at the clues. You're going to analyze it. Tell me if this makes sense. Remember the octopus, his muscles were cramping up. Isn't that similar to when the windows and whatnot and your program freezes up and whatnot? And that has happened on every computer program. The bridge represents the internet. That's your connection to the outside world. And whenever the internet goes, doesn't this appear on Google, the little dinosaur thing? All right, so y'all can probably read the clues there. I hope it made sense, and I hope you had fun. All right, so take care, guys. Enjoy the rest of the holiday. Right, so Jordan, you tell me you want to go back to a question? I think it was this question, right? All right, great. Take care.